Hello, everyone, and thank you for joining in on this webinar. We'll just give the last people a few minutes to join in, and then shortly we'll be starting the webinar. It's always fun to see where people are joining in from, so you're more than welcome to write in the chat where you're joining in from, and then we'll start in just a few minutes. Thank you. So just before we're getting started, just to get us all on the same page, I'll run a small poll that I'll hope you will be answering in terms of how much experience you have with temperature mapping, and hopefully that can guide us through what we'll be focusing in on today. As well, I'd like to notify you that it's possible to use the questions tab in your interface, so that if you have any questions along the way, or if you already have some questions, we've already gotten the first questions in, you're more than welcome to type those in, and we'll be uh, answering some of those questions along the way, and then we have a Q&A session at the end. But in just around 30 seconds, we'll start up. Hello, everyone, and welcome to this webinar on risk-based temperature mapping. We're very excited to see a lot of people joining in. Some of you for second, third, and fifth and fourth time. There's definitely a lot of people. Hopefully, yeah. So we see a lot of people that are rejoining. It's very nice. Today we'll talk about risk-based temperature mapping, and just to get us started, there's a small poll in terms of how much experience you guys have with the temperature mapping, and it seems to be quite evenly distributed. There's a lot of both beginners, somewhat experienced, and very experienced. So that's very nice. Hopefully today we'll touch base on a series of different levels. I should mention that we also do have a lot of other webinars that you can view on demand if you want to get into temperature mapping with some of the introductory webinars. But other than that, let's just get started. I'll close this poll down, and then we'll get started with the presentation and the topic of today. So starting off, I'm sitting here with Mads, who is a specialist within some of the products that we deal with here. He's a senior product specialist here at Ubri, and we'll get into what we do here at Ubri in a short while. And my name is Jacob, and I'm the head of quality at Ubri, where we have a team of validation engineers working with all of our customers, or many of our customers, in terms of doing temperature mapping as part of our temperature compliance program. We have experience from hundreds of different mappings in GXP industries. So hopefully today we have the opportunity to share some of those experiences. As I said just before, you're always welcome during the webinar to come with your questions, either through the questions button on your screen or in the chat, and we'll try to answer some of those questions along the way. Furthermore, we have Chelsea and Philip sitting on the chat. Hopefully they can answer some of your questions along the way and provide you with some links as well. So, without more further ado, I'll leave the stage to Mads to give an
Perfect.
introduction of who we are here at Upre.
Thanks a lot. Thanks a lot. Yeah. So, yeah, just to give you a high level introduction at what we do at Upre, we are essentially a company which is working around temperature compliance. So there's obviously a lot of different things that is, combining that. We work very much with validation and mappings, which we're discussing a bit more today, but also temperature monitoring, calibration, and really trying to utilize different technologies in terms of combining all those different solutions. How can we make them more digital? How can we streamline processes and so forth? So that's really a lot of the different things from a high level perspective in terms of what we are working with. Yeah.
Absolutely. Yeah. But let's get started with what are we going to talk about today. So some of the different topics that we'll cover today is, first of all, we'll do a baseline. What is the mapping process, and what does it look like in a GXP environment? Um, we won't use too much time on going down to the different specific topics of the mapping process today. What we'll actually be focused on today is how to identify risk in a temperature mapping. How do you use the risk-based approach, and where are some of the most important points where we use the risk-based approach in a temperature mappings? Furthermore, we'll go through some of the common pitfalls. We see a lot of different companies within GXP. GXP is a quite wide industry, so we're working all the way from point of sale, distribution, up until GMP production. So we see a lot of the different things, and we'll try to summarize today with some of what do we see out there, what are some of the common pitfalls as well. And then we've added in something which we call best practices. I think we might as well call it what would we do.
Yeah,
Basically,
maybe.
some of the topics that we feel we see a lot that work for our clients, that work for us when we perform these temperature mappings. So hopefully we'll bring some of those forward. And again, please don't hold back in terms of asking questions along the way. It makes these webinars a lot more live, and it gives for a very nice discussion along the way. But I think we'll just jump right into it.
Let's do it.
So first of all, working with the mapping process. I should mention there are a lot of different guidelines and standards that outline the mapping process. The mapping process is a part of process validation. I think that's one place where we see a lot of misconceptions regarding the mapping process. But mapping should, in my mind, be viewed as a part of OQ/PQ, as part of an XQ, like a installation, operation, and performance qualification. So it is the final step of ensuring that facilities, warehouses, fridges, freezers, incubators live up to the requirements that are set out in the process requirements or user requirement specifications of any process. And we tend to see a lot of misconception in the fact that mapping is a part of validation because the process that you are validating is the storage process. So I often like to say that it's a good way to think about the process being storage, and how do you specify your requirements for storage, and thereby also qualifying the equipment. There are other parts to qualifying and validating the storage process, but mapping is a major part of it.
Yeah.
And it's also one that we get a lot of questions to. So what should you take away from this? Mapping is a part of the process validation. What does it consist of? Well, the main components of performing a mapping are creating a protocol. The protocol describes what should be done, what are the different considerations that were taken into account when deciding the strategy and the methodology. So basically describing what are our requirements, what are we mapping, and how are we mapping it, and the rationales behind choosing different data logger positions, as we'll get into at a later point today. What was the rationale behind choosing that specific strategy? So what was the extent, the scope of your mapping? That should all be defined in the mapping protocol. And that's also going to be the first document that an auditor would like to see, is the protocol, because that's where you plan out what is your mapping, what does your mapping consist of, and to what extent does the mapping cover your requirements. The next part is the execution phase. So that's where you actually go out and place data loggers, collect data, um, document what you've done, and basically also the place where you gather a lot of different information as to was the protocol where in which you describe how the facility was that actually accurate, or are there any considerable differences between what you planned for and what was actually on site. And lastly, you have the reporting phase, in which you gather and analyze the data. You analyze whether your facilities and the data you have cooperate with a conformant storage conditions. So basically, it's the conclusion of your mapping studies. That's often, or that's not often, that's also where you define the requirements for continuous monitoring. So the mapping study report should be a standing point or a start point for defining your ongoing monitoring strategy. So how do you plan to use the data from that, both in terms of the standard operating procedures that you'll be operating the facility or the equipment under, but also where do you plan to place data loggers going forward. That was a very quick introduction to the mapping process. There's a lot more to read about this, and we also do have some online reading material that we can provide you with. So without further ado, I think we'll move on into what are some of the areas in which the risk-based approach can be used in temperature mapping. So the risk-based approach has been widely adapted by different regulatory bodies over the last, I would say, 5 to 10 years. And a lot of the mapping standards and guidelines out there also incorporate risk-based approach in their recommendations for how to perform temperature mapping. There are some specific points, though, where, in my understanding, the standards and guidelines provide a set of general recommendations, but they do not provide the rationale behind the underlying risk assessment that led to those different recommendations. And this is what we've drawn up in this small graph here. So if you go through the WHO guidelines, if you go through the ISP guidelines, if you go through the PICS guidelines, you'll often see different recommendations for how you should perform mapping, how often you should do it, and where you should place sensors. But where they sometimes fail is in explaining the underlying rationales behind those recommendations. So as an example, one of the things that will be described in these different guidelines are that you need to perform a summer and a winter mapping. But in order for you to be able to apply a risk-based approach, you need to understand why do they recommend summer and winter mappings. In this case, it's basically because there's a risk that seasonal changes might impact the temperature, distribution, homogeneity, even compliance of your facility, your fridge, freezer, whatever it might be. So the underlying risk analysis that they've made when they made those recommendations is that seasonal changes might have an impact. Another example is there are often a lot of placement rationales or placement recommendations, sorry. So they'll state stuff like you need to place data loggers in the corners. There needs to be data loggers in the center, data loggers near doors and gates and whatnot. And that's basically because the underlying risk is that there might be inhomogeneities. And what do I mean by inhomogeneities? That means that the temperature is not the same for all positions within a warehouse, as an example. That's why I need to place the sensors. There's also a risk that the temperature is not stable. And that's why you need a lot of different data loggers at different positions in order to determine temperature stability at those different points. So there's a whole risk analysis that you need to perform if you want to adapt the risk-based approach. Another great example are door opening studies and power failure studies. Well, why do the guidelines recommend power failure studies and door opening studies? Well, it's because that is a risk. It's a risk that if there is a power failure, that the temperatures will be non-compliant. And it's a risk that if you do open the doors for certain periods of time, that the temperatures might be non-compliant. And what we see sometimes auditors looking for is when companies have chosen to include door opening studies and power failure studies, that they do not have the underlying rationales or risk assessments behind it. Um, it's one of those things that we see auditors increasingly starting to probe whether you understand the risk assessments that were the baseline for choosing the different methodologies, and especially if you're choosing not to include door opening studies and power failure studies. I don't know if that's something you see reflected as well in terms of when we get in touch with our customers.
I think, definitely it is. I think from a general perspective, when we speak to customers, it's always this, I think a lot of these different, test plans and so forth, like when you start designing the protocols and kind of like what is the different risk, and like it's a really interesting topic to kind of dive more into with the customer, because it's always different from case to case also, in terms of what is their operation, say like how are they on the normal operation kind of acting, whether or not it's a warehouse, is it a fridge and freezer, and so forth. And obviously it just becomes a very, at least from my point of view, it's a very interesting conversation just to have with different companies, because it touch bases more on their operation, and it's just different from company to company.
Yeah, absolutely. There's great variations, and I think also we see that when companies start to understand the underlying risks that they're trying to mitigate with the risk-based approach, the mapping strategies are much more aligned with what gives value and what is actually beneficial for the process that we're trying to validate.
Yeah, I mean, it's obviously like a lot of it is also moving it, like it's a lot of data, and the conclusion behind it is also something you can use moving forward as well. In terms of what, how should your standard operation procedure actually look like in terms of the opening of a fridge and freezer if you have very sensitive products in there, and so forth. So it's an interesting topic.
And we actually got a question here which lines perfectly what we're talking about, which is basically there's a question: do summer and winter mappings need to be completed on storage unit held in a CNT and a controlled room temperature, I guess, environment? And that's spot on, because what is your risk here? If you have a unit that's stored in a temperature controlled environment, is there then a risk that seasonal changes will impact the storage conditions? In most cases, no. So you can actually use your understanding of the underlying risk assessment to optimize your processes, so that you can argue, no, we do not need to do seasonal changes on controlled temperature environments that are stored inside environments that are temperature controlled. So that's the exact line of thought we want to be going for. Thank you very much for everyone who included in the debate here. So some of these questions we'll get to in a while as well. So there was another question here, but then we should have some type of consideration for power failure studies, right? And exactly, one of the best examples I see is that for power failures is, we get a lot of questions: do we need to have power failure studies? And I would turn the question around saying, is there a risk that power failures are relevant? So what do you need for that risk assessment? First of all, there's infrastructure. If you live in a region or a country where there's a high risk that infrastructure might fail and you might lose power, well, that increases your likelihood that you need to perform a power failure study. Secondly, do you have power backup features in place? Well, if you have a power backup system and that has been tested, well, then you're most likely not going to perform a power failure study. And then lastly, sometimes you can use the mappings to gauge what your risk is. So what do I mean by that? So when performing a power failure study, you will actually get information on how long time do we have from a power failure until we get non-conforming temperatures. So that's a sort of a reverse risk assessment. So what we often advise our customers to use that information for is, let's say you have a warehouse, you have a power failure study during a summer period or hot period. It will tell you that you have, let's say, 11 hours to respond. That information should go forward into your standard operating procedures, so that you know and you can test your business continuity in how fast can we get power back up and running. So it's that recursive process that you need to focus on. So yeah, so for the sake of time, we'll move forward. I just want to the last thing we often get a lot of questions on is how to do what should our remapping frequency be, and that's again a place where a lot of the standards that will give you some idea of what the frequency should be, but in this case they also do give a lot of recommendations on when to do remapping. That's one of the things we'll dive into today. A lot of great questions, by the way. So in order to really get started on this, one of the key elements where the risk-based approach is valuable is how to place data loggers. It's really one of the things that are widely debated, I would say, but there's also some very found risk assessment basis on this.
I think it's also the number one question we get.
Yeah, absolutely.
It's how to place the
And
lockers.
it really is one of those things that can be quite difficult if you don't work with them continuously.
Definitely.
So we have the question again, exactly how do we determine the number of sensors needed to do a temperature mapping? And that's exactly what we're going to deep dive into here. So in UPRI, we've developed our own approach to, or methodology to approach risk-based sensor placements. So we have a model in which we have 3 different categories of risk that we use when we develop protocols. And that takes into account, first of all, compliance risk. And what do we mean by compliance risk? Basically, it's if you choose to follow some of the standards on temperature mapping, which we highly advise doing, there will be some recommendations for the number and placements of data loggers. If you deviate from those guidelines, well, you have a risk, and the risk is basically that you might be non-conformant to the guidelines. That should be included in your risk appetite. How willing are you to take the risk that an auditor might disagree with your propositions and say that you're non-compliant to the guidelines? That's the first one. The second one are technical risks. So those are basically risks related to technical installations. That can be HVAC blowout air, that can be charger station, which can produce heat. It can be windows, doors, gates, everything that can disturb the homogeneity and stability of temperatures to be within the acceptable range. And then lastly, we have operational risks. And operational risks are related to how you use the facility or the equipment. So that can be, how do you plan to load and unload goods? For a fridge, for example, how often and do you open and close the door, and for how long time? And that's another risk that we need to identify so that we can know where to place our data loggers during the mapping studies. So going back to this model that we presented before, we focus in on placement recommendations. So at the bottom here, you see some of the general placement recommendations that the guidelines will provide you with. And on the top, there's the underlying risk. So as an example, a really good example is that the guidelines often have a recommendation that you should place data loggers in the corners and center of the placement, and they'll have a maximum distance between data loggers where you need to place them. Well, the underlying risk to that is that the homogeneity and stability of temperatures inside the volume is not within specifications. So if you understand that, you can use that and rationalize where you place your data loggers. The next thing is placement near walls and doors. Well, the risk there is that external influences will make some of the temperatures that you observe non-conformant. So rather than just choosing to stay with the recommendation to place data loggers near walls and doors, place them where you have external influences. So identify, where do I have anything that externally could impact the distribution of temperatures, and then place a data logger near that. And the same thing goes for placing data loggers near HVAC systems. It's basically because you have non-conformant blowout air. And I won't go into too much detail with the rest of it, but basically understanding why the recommendations are made as they are give you really good rationales for choosing your own placements. And I'll almost guarantee that you'll get a happy auditor, because you've explained and you've shown that you know what you're doing and you know why you placed your sensor loggers where they are.
I think a question that we often get as well, and you touch a bit on it just previously in terms of, if you have a fridge, which is in a temperature controlled environment, that is obviously a good thing to have it. But we also see, and we get the question a lot also, is that some companies still place a locker in that room. Same thing if you're doing a warehouse, you place a locker outside. So what is sort of the different considerations that companies should take in terms of, like, should we actually have a locker when we have a fridge in a temperature control room? Do we need to have a locker outside as well, like in that room?
Oh, that's a really good question. Again, I would say, what are some of the risks that are posed to this fridge? So the whole rationale behind choosing summer and winter mapping is that the external influences will be so large that will be reflected on the temperatures of the products inside the temperature controlled unit. So I would say, as a rule of thumb, again, I'm against rule of thumbs here, but is that fridges are normally sort of resilient to temperature changes of like something like 10 degrees Celsius. We have customers from all around the world, 10 Kelvin. So in a normal warehouse or in a temperature controlled room, not necessarily one that is closely monitored, will have very few variations in terms of temperature. So, but yeah, it is basically a risk, and also utilizing the information from the manufacturer is often usable. So using that to say, well, they guarantee operation between this and this temperature, and those are ranges that will most likely never hit. So in that case, our risk assessment is that it's okay to do it at any season and basically use that as both summer and winter. But then again, if you observe highly fluctuating temperatures, it might be a good idea to
but is there any value in terms of, like, from a when they're being ordered, like from that perspective, on like just having the data to sort of like prove that it isn't in a controlled environment as well? Like, does that give value as well?
It does. We do see that gives value, and we do see that that's something auditors ask for. I would say the accuracy at which you need to have that data is maybe less. I mean, you could have wider ranges. So normally for any temperature controlled environment, you would need to have a calibrated sensor that is qualified and the system validated to provide accurate data. We don't normally see that requirement imposed on just basically room temperatures, where you want to measure the room temperature, just to guarantee that the fridges or freezers were not exposed to extreme temperatures.
No, it makes sense.
Great question. We're rushing away here. So some great questions. We see a lot of your questions here, but I think a lot of them will go through in just a short while. Other than that, we'll pick up at the end here. So in terms of the sensor placement, just to get really specific again, the grid placements, which are the ones you place in your corners and the center volume, know that those are based on a risk that there's an homogeneities. So you can use that in order to often lower the amount of sensors. And secondly, doors, gates, and windows, those always pose a risk. We rarely see that doors, gates, and windows do not have some impact on the temperature. And in that case, those should be monitored. And we often do see in larger warehouses that at least 50% of doors, gates, and windows should be monitored, because it does have a great impact. I'm missing my mouse here. So thirdly, blowout air, that's also one of the large contributors to inhomogeneities and instabilities of temperature. So that's basically when you have your temperature control system, your HVAC system, where the air is leaving nozzles or fans, that air will have significantly different temperature than the average temperature, and that should be monitored if there are products near that. So that's often one of the points that's very important, is that, well, you don't need to monitor the blowout air of an HVAC system if it's nowhere near any products, because then there's no risk to product. So again, remember, we're talking about risk to product.
Yeah, exactly.
And that's the key element here. And then lastly, one of the bigger risks we also see is that you'll have heat generating equipment. Forklift chargers is a really great example. Those generate a lot of heat, and they tend to generate it when they're plugged in, which tends to be during nighttime when everyone has left the warehouse. So that's really one of the places where we can see that there are alarms being generated, and it will always be when people have left
Yeah, exactly.
job.
Yeah.
So it's one of the key things to keep in mind. Another thing we see are office facilities. Those will also create heat, and it can be one of those things that if you do an initial mapping of, let's say, a warehouse, it's often not with the people working there. They won't be sitting there with their personal computers, their screens, their monitors, everything. And that means you need to be extra cautious, because often we see when performing an initial temperature mapping, it will be without the people having the computers and so forth. So it won't be present in the mapping data, but it's a risk that you should identify when you know how it's going to be used further on.
I think there's just a great question that
Yeah.
we also get a lot, is can you calculate it just based on the square footage, for instance, or
Yeah,
square
oh, yeah,
meters?
exactly. It's a great question. So if we start out by what the standards are, they're both the WHO guideline, which I'm sure Philip can link in the chat, and the ISPE guideline, which is something you need to purchase. They have clear recommendations of how far spaced sensors should be.
Yeah.
What we often do see, though, is that the number of loggers you would require with those requirements is way too much. And that's why the risk-based approach is often the solution. Because if you were to blindly follow the guidelines, you would have hundreds of loggers in even very small warehouses. And um, using a risk-based approach and justifying why you need less loggers but in more strategic positions, we have yet to see that fail with an auditor or get in sort of non-compliances. So to answer that question, it is possible, but it should rather be based on a risk-based
I think it's also, and you mentioned it a bit in terms of, because obviously you can have a size of a warehouse, but it might only be half of it that you're using for storage
yeah
as
yeah
well.
yeah
So that's also something to take into consideration, that it's not necessarily the whole room.
yeah
And also in terms of height, like it might
yeah
be a high room, but if you're only storing at ground level, then you don't need 3 or 4 levels of
yeah
lockers
yeah
and so forth. So there's a lot of different things that you need to take into account when you actually start calculating in how
yeah
many
yeah
lockers you actually need. Yeah.
absolutely. uh, Great questions, thank you very much. So moving on to the next point here, where risk-based approaches is really relevant, is in terms of the test scope. So a test scope would often involve, do we need to perform summer and winter mapping? And I think we touched base on this early on as well. It's crucial to identify whether summer and winter will have an impact on the stability, homogeneity, and conformance of your temperatures. So again, now we had a lot of questions on this, but basically, can you, to whatever degree, um, guarantee that the outside influences will be minimized to a point where it's not really relevant anymore? Well, then you don't need to perform summer and winter mapping. And I always try to show this picture often because it's a great example of how temperatures can be greatly different during summer period than winter, because we might have sun-facing sites and we might have shaded sites, and those or shaded walls and sun-facing walls, and that is going to be a great impact on the distribution of temperature between summer and winter. So that is clearly one of the things you need to consider. And for buildings that are temperature controlled but also facing the outside environment, I have yet to see the rationale that justifies that you don't need to perform summer and winter mapping.
Yeah.
So in most cases, the question is yes, you do need to perform summer and winter mappings. The next thing is related to door openings. So again, you need to have a good understanding of the process that you're trying to validate, the storage process, because that's going to forward your requirements for exactly how do you need to perform this mapping. One of the examples we often see where auditors are not really satisfied is that the door opening studies that were performed were not really based on expected usage of the equipment or actual usage of the equipment. So again, you need to identify what is my risk. Well, if we're opening up this freezer 20 times a day and it's for 30 seconds at a time, your testing scope should cover that. Otherwise, you can't mitigate that risk. And that's really, and we'll get back to this in terms of when to perform remappings. But basically, if you've if you have performed a mapping in which you test, let's say 20 times a day, 30 seconds per time, and you start changing that to 60 seconds per time, 100 times a day, that is a major change, and you need to perform a remapping in order to ensure that that does not pose a risk to the product stored. Moving on here again, power failure. I think we touched base on it earlier due to the great questions coming in. But then again, is there a risk of power failure? Well, how great is your risk appetite? In most cases, it's not very big in terms of a power failure. So if there is a chance and it's likely, then you need to perform a power failure study. One of the methodologies we like to use as well is this impact/likelihood scheme. So the impact is great in most cases. So it's just a matter of determining the likelihood in order to get your final risk score. And then we get into the whole question that we often get as well is how and when should we perform remappings? There were also some great questions regarding this issue in terms of how often you should perform it. And again, the risk-based approach can really be used. A lot of the standards and guidelines do make really great recommendation as to what you should consider when reviewing your data and determining whether you want to do a remapping. And Leon will actually get to that exact question right here. So thank you very much for asking. So first of all, I fundamentally disagree with the concept of having a frequency of mappings. Like stating that every 3 years you should do a remapping, for example. That's the anywhere between 3 and 5 years is the normal interval for let's say a warehouse. What you should rather do is to make a review interval. So you should, in my opinion, you should set up an interval at which you will review. And what should review? Well, those are the exact things here. Those are tendency indicators and changes. So basically anything that can provide you with an insight into are we going to a state where we have a greater risk of this being non-conformant? And what are those? Well, first of all, those are alarms. Looking into, do we have a lot of alarms? Do we have a lot of non-conformant temperatures that we do not used to have? And also, what are the general temperature data from your data monitoring system or your temperature monitoring system? So looking over greater periods of time, let's say a year at a time, it's actually possible to spot tendencies going towards more unstable temperatures or increasing temperatures. And that can give you an indication that there might be degradation of material, which means that you need to perform a remapping. And this is actually what I've tried to explain here. So looking at general tendencies of temperatures within your equipment, and that can be anything from a freezer to a warehouse. Having a large view and review of this data. And then lastly, looking at whether there are any sort of major material changes to your equipment. Have you performed any changes of the HVAC system? Has there been ongoing changes to doors, gates? The sealing of one of the issues we often see is that the seals on fridges and freezers degrade over time. So have you performed regular maintenance on those? If not, well, there's a greater chance that you will have to perform a remapping because there's a greater chance that the temperatures are non-conformant. Great question. I'm just looking here to see what the any topics. Now we'll gather a lot of these later on. So that's basically a lot of some of the key points where we see the risk-based approach being useful in temperature mapping. So now we'll go into some of the common pitfalls, and this is basically based on the hundreds of mappings that we perform each year here at Europri, and some of our experiences with that. So um, going forward here, first of all is having the right rationales. Basically, your risk assessments. We see a lot of times that people do get notifications on notions from auditors because they, our clients have performed risk assessments, but you have not described well enough what was the rationale behind choosing a specific methodology. And those are basically the risk assessment, or sometimes we call them rationales. Why did you choose X, Y, Z, and what was the risk assessment behind it? It needs in order for it to satisfy auditors, it needs to be well described and well thought out. Um, and the second one being a lack of understanding of the process. So we touched base on it before. How often do you plan to load, unload goods? How many people are walking in and out of warehouses? How often do you plan to open and close fridges and freezers? You need that information, or at least an assessment of that information, in order for you to justify your mapping methodology. And coming back to the remapping issue again, if you don't know what your state was in terms of your process, how you used the facility when you did the mapping, if that changes, that's also a major change that causes a remapping. So let's say you're unloading 3 trucks a day. We see this often, right? You start out slowly with a warehouse. You unload 5 to 10 trucks a day. You perform the mapping and you test it based on the assumption that you will load and unload 5 trucks a day, and suddenly you're at 100 trucks a day. That is a cause for a remapping. And it does not matter that it hasn't been more than 6 months, 12 months since you did your last mapping. If you change the use of your facility, you need to perform a remapping, or at least you need a very good justifications or ongoing verifications in order to ensure that you don't need a remapping.
I think that's also, I mean, that's typically also the most common thing that I hear is it's just the whole, sometimes just taking a step back and kind of looking a bit from the outside, looking into it, saying, all right, what do we actually need to do? I think is the most common thing that we also, as a pitfall, so to say, that people fall into. Yeah. Because I think a lot of our companies also they tend to look for the guidelines, saying like it must be written somewhere. What I need to do, and it's not necessarily always written somewhere. It might be written that you need to at least have an idea about it. And a lot of it obviously leads back to just taking a step back and kind of thinking about what is it actually that we're going to do. And then obviously testing that.
And that actually leads us really good. Thank you for the question, Leon. If a need for remapping has not been justified, how do you decide when to change hot and cold spot position monitoring in seasonal change? That's actually a really good question. So if I understand you correctly, the question is basically if you perform a mapping during winter and one during summer, and those have different hot and cold spots, do you then switch around the sensors? That's also one of the questions we get a lot. Do you switch the position of the constant monitoring system? We would normally advise not to, but basically to keep a sensor in each position. And the rationale behind that is that you don't know when exactly the hotspot changes. Furthermore, we often like to say as well that even though the hotspot might be in one specific position, it's much more likely that it's an area that will be the hotspot. So often we'll find that the hotspot and cold spot does change, but maybe not by volumetric wise that much. So yeah. Oh, sorry. And the last part for the common pitfalls here is requirements traceability. So we see this a lot. I think especially in the GDP industries that starting to think about mapping is something that comes in very late in the building and validation and qualification process. But basically, you need to be aware of what your process requirements are from the very beginning, and the earlier the better. And that's everything from what temperature span should it be, what's our acceptance criteria, the most basic, but also how much do we plan to move in and out, so that during design of the areas, you can actually get a design qualification, or at least a subject matter expert to verify that your design of your facilities will hold those requirements. And then linking those to how you perform your mapping. That's a very crucial phase. And the auditors get absolutely excited when you can show that you knew what your requirements were and that you're testing those requirements in your mapping. And I would also turn it around and say it's impossible to write a mapping protocol if you don't know what your requirements are.
Yeah.
Something that we tend to see that's being sort of added on at a later point, but it is really crucial to have a good traceability between your requirements and what you're actually testing.
Yeah, I think there was another question as well, which I think was quite relevant. Is the concept of doing an empty load and doing a a loaded warehouse or fridge and freezer, and in terms of, let's say you are in a warehouse that already has product and now you need to do a mapping. Do you need to empty it and do an empty?
That's a really great question. So again, I would always advise looking to the risk. Why do they recommend empty and loaded? Well, the risk is that there might be airflow issues. The guidelines are actually quite well described on this topic, but the risk is that when you start filling in products, airflows might be disrupted, which means that temperature distribution might be uneven or might create areas of colder air and hotter air, or whatever. So on that basis, again, one of the things we often advise is saying, what is it? I'm against the term empty and full mapping, because that's not your risk. Your risk is on minimal loading. I mean, if there are no products in the warehouse, what risk does that pose to products? Well, there are no products. So, I mean, empty does not make sense. That's the first thing. Minimal loading would be a much better terminology, because you want to test out what is the airflow and distribution of temperatures at a minimum and your maximum loading. So on that basis, I would say, yes, you do need to at least take it into account when performing your methodologies. And often what we see is that, well, minimum loading could be simulated by an empty warehouse. So in practice, it will be an empty warehouse. But again, the maximum loading scenario can often be achieved by either having cardboard boxes or wrapped, like plastic wrapped areas again. But you need somehow to get relevant data from your mapping studies. The ISP guidelines do give a concept in which you can, if you have symmetry in your warehouse, so basically you have a large square warehouse, well, you can divide it into smaller sections that are alike, and you can perform a quote unquote full mapping on those areas separately. Because yes, it is most likely impossible to achieve a full loaded warehouse during a mapping study. It's often not economically feasible as well. But yes, it is a great concern, and you really do need to take into account the risks associated. So just moving on here, please keep the questions coming. So these are our 3 best practices. What are some of the best things to do? So in going away from what you should avoid to what are some of the things you should do in our end. First of all, you should use risk assessments and the risk-based approach, and you should document it and keep it. A risk assessment is worthless if there's no a risk-based approach is worthless if there's no risk assessments. Those should be documented using good documentation practice and so forth. It's very easy to get this right, so just get it right the first time. Secondly is go on site. As a validation engineer, it's sometimes very nice and comfy to stay in our offices and perform or create these protocol, but we often see that going on site will give you a much better understanding of what the situation is like. And you'll have a much better understanding of where the risks are as well. You can't put everything on a floor plan, and sometimes just going on site gives you this great idea of, well, oh, there's a forklift charger there, there's a window there, there's not drawings and so forth. So your protocol will just increase tenfold in value if you go on site and
I think at least, I mean, if you don't have the option to go on site yourself, at least have somebody on site that can kind of
yeah,
do the
absolutely.
route
Good
for you,
point. Yeah.
and so forth. Yeah.
Absolutely. And then lastly, if I can get this working, we have create a qualification policy or validation policy. What I mean by that is basically auditors are very happy to see that you've considered on a general level, on a policy level, how do you plan to qualify and thereby also map your facilities and your equipment. That means that you've, from a central place, quality assurance has taken a stance on how do you define your methodologies in general. It doesn't have to be very, very specific, but basically that you show you have a commitment to qualify your equipment by different strategies. And that is something that can be used when authoring protocols, when dealing with daily quality work. So that is basically something that auditors are very happy to see, and it also gives great confidence when writing protocols and reports that they back up on the same policy.
Yeah, definitely.
So at the end, we have a bit of time. We have 7 minutes left here for a bit of Q&A. So we'll go through some of the questions that came in.
I think there was one that just came in a bit higher than that one. This one from Leon as well. Is the period of the mapping is a really
a great question again. Thank you, Leon. You should be on this webinar next time. So Leon asks, what would be the suggested period for a mapping, and should it include? Inactive non-working days? Great question. So yes, and that's also why I would always recommend that the minimum mapping period for any type of equipment basically should be 7 days, especially for larger units. First of all, there's a great risk that these large systems take a long time to stabilize, and they will, if they have any variations or stability issues, those will take a long time to show in the data. That's the first thing. And then secondly, again, if you have let's say a performance qualification with people actually using having normal work days, there will be major differences between when it's used and when it's not used. And then thirdly, it's so easy. I mean, once you have the loggers set up, they're transmitting data wirelessly. There's, whether you choose to take along 2 more days does not impact greatly on the project time or the project cost.
Yeah. What is the difference in terms of looking at a warehouse, looking at a fridge?
That's a really good question. I think again it has to do with sort of the response. How long time does it take for the system to respond? And it's a really good question, because like something like a fridge or freezer will adapt within hours. You can just see it if you turn on a fridge or freezer. It takes a matter of hours, not days, to stabilize. So in that sense, it's much easier to evaluate in a shorter period of time. So with normally our rule of thumb is that if you're working with smaller units, incubators, fridges, freezers, something like 24 to 48 hours is a minimum. But if you're working with much larger systems like warehouses or controlled temperature chambers, like walk-in coolers, something like a week, maybe 5 days, also covering a weekend, would be a good idea. So I see there's a lot of question here in terms of the permanent location. So why do we, I would take the risk-based approach again in terms of where do you place the constant temperature monitoring sensor, and when it changes from summer to winter. Again, why do we place the sensor in the hot spot and the cold spot? That's because that's where we'll see when we have non-conformant temperatures first. So let's say that your facility is affected by summer temperatures. Well, the hottest temperature, the spot with the hottest temperature, we believe or we estimate that if the temperatures are non-conformant, that hotspot will be the first spot to have non-conform or too high temperatures. So again, it's part of your risk appetite. If you do not wish to change the permanent logger position from summer to winter, you need to quantify, well, can I lower the alarm value and that will give me early warning, or do I need to accept that risk? But I can guarantee for the cases we see, auditors will not be satisfied without you at least understanding the risk of not placing your constant temperature monitoring in the hot and cold spots. So there's a great question here from Jordan. As an auditor, is there anything that I should be specifically looking for other than the ones you've just been outlined? I would say what we see other auditors looking for is, first of all, I think one of the key elements that we haven't mentioned today is good documentation practice. Can you actually trace back the actions that were performed to specific people, and have those people been trained? Temperature mappings is one of those things that seem very simple, and that way we also see a lot of people without training performing temperature mapping. Is not to say that you need extensive training, but at least understanding the concepts of where to choose loggers. I think a very good example of that is something we've gotten into in previous webinars, is when you choose a position for a data logger, you choose a rationale which defines where to place that. So if you get to a spot where the rationale is in blowout air from HVAC system, and where you drew that dot on the map, there's no blowout air, well, then you don't satisfy the rationale. You should move the position physically and know that as a change. That's one thing that you need an understanding of the mapping process in order to do. Yeah.
I think also a very easy one to sort of get around in terms of what you also need to be aware of is obviously the equipment you use for performing a mapping. Like, is it calibrated? Like, check for that the equipment you're actually using for performing the mapping has been calibrated and is within accuracy, and so that you can actually trust the data that you're seeing.
Absolutely. And also what we're also seeing a lot of auditors starting to focus on is the data analysis part. So if you're using any sort of system to base a GXP decision on, it needs to be validated. And one of the things we see is that if you use something like Excel to validate your data, you need to validate that Excel sheet. And if you're using a software system, ensuring that that system has been validated for the intended use. I think we'll have time for maybe the last question here.
I think while Jakob is finding something to go through, I think there will also be sent out an email, and I think also Frederica or Philip will send it here in the chat as well. If you want to have a call with me to go through some of the things that we've discussed today, some of the questions that we didn't answer, or just in general, kind of, if you have a mapping project coming up that you would like to kind of have our eyes on, feel free to book in a meeting with us. It's free of charge. It's just a conversation. If there is any of these risk-based approaches and so forth that you would like to adopt into your next mapping, just book in a meeting with us. We are more than happy to.
Yeah, and I think we're running out of time.
Yeah.
So, but thank you very much, everyone. It's been a great pleasure. It's always great when there's so many questions. If you're interested in other in the topic of temperature mapping and temperature compliance, please do follow us on LinkedIn and follow UPRI on LinkedIn. We are posting something like weekly with the articles regarding temperature compliance and mapping specifically as well.
Yeah.
So, but thank you very much, everyone, for attending. It's been a great pleasure. And
we'll see you on the next webinar.
We'll see you on the next webinar. Have a good time.